negative 8, right? Okay, so 1, 2, 3, 4, 5, 6, 7, 8. And it looks something like this. I'm not even worried about where the y-intercept is yet. When you get to negative 8, here's what you have to do.
My graph doesn't go on the other side.
Pardon?
It doesn't go on there.
May I see? Yes, it does. That's a resolution failure of your calculator. See, if you trace to like negative 7, it's got a value. It's just really small. It's very, very close to the x-axis already.
Is that what it's
So it's there. You got to be smarter than your calculator. Yeah. Now trace to negative 8. So here's how you have to graph this by hand. If I give you this to graph, and you just graph this, you're going to be mostly right. But you have to put this buttonhole at this point.
Because it's a removable.
Exactly. It's a removable discontinuity. And that
You have multiple. No, you can.
yeah, you could. Actually, it'd be really easy to do. Let's just say, if I just put, say, x here and x here, Drew,
Yeah.
so that this would be x squared plus 8 over x cubed minus 64x,
Yeah.
then that would create a removable discontinuity at 0. Because then when x was 0, I would again get 0 over 0.
Okay.
So I can create as many buttonholes just by multiplying the top and bottom by the same factor.
Okay.
But when you take them out, you get something easier to graph, but you must remember this buttonhole is here. If you leave that off, I'll take off major points on the graphs you do by hand without a calculator on the next test. Okay?
That's weird.
So that's the removable discontinuity idea. You can graph something simpler, but you have to remember the buttonhole. Adina raised a great point. When we're working on these algebraically, or when you're reducing these things, other times we do this, we ignore this, because it really doesn't matter until we get to graphing it. But technically, every time you said this reduces to this, you were actually supposed to say this is equal to this except when x equals negative 8. Some old textbooks actually show that in all the answers. And some old teacher's guides say don't give credit unless the kid puts that in.
If I put that in from now on, will I get extra credit?
I like how you're always strategizing, Adina. James, follow me back over this way now. Next example. A couple more of these. Rational expressions don't always look right when you first see them. And that can be, in my humble opinion, exciting. So, for example, if I said I wanted you to graph 1 minus 3 over x plus 2 over 1 plus 1 over x minus 2. Did we cover any that look like this?
No. Wait, is this
No.
something like
Yeah, this is a new example. New example.
new, like,
Not a new idea. It's still rational expressions. Okay?
A question.
Yes.
Wouldn't you multiply both numerator and denominator by x minus 2? Or x plus 2, I don't remember which.
You could multiply them by both. You're on the right track. Your goal is to get rid of the complex fraction. Get rid of the complex fraction within the fraction. One way to do that is to multiply top and bottom by whatever's in a denominator on that. There's a slightly easier way this way. Because for that strategy, you'd have to use x minus 2 over x minus 2 to get rid of the bottom. And then you'd still have this up here, so you'd have to multiply by x plus 2 over x plus 2 to get rid of the denominator in the top. So that should be problematic. I want to make a common denominator top and bottom first instead.
oh, can you multiply the bottom by, wait, no.
Here's what I want to do. I want to change this 1 into x plus 2 over x plus 2. Minus 3 over x plus 2. And I'm going to change this 1 on the bottom to x minus 2 over x minus 2 plus 1 over x minus 2. Johnny, I heard an aha from you.
Then you can combine them.
Then I can combine them, right? Now, technically, Adina, based on what we just said, if I change 1 into x plus 2 over x plus 2, I should note somewhere that 1 is only equal to x plus 2 over x plus 2 as long as x is not equal to negative 2. Otherwise, I'd get a 0 over 0 there. But I'll be honest, I'm not going to do that here. All right? So now, this is going to make it x plus 2 minus 3 over x plus 2, all divided by x minus 2 plus 1 over x minus 2.
Can you pull out like a negative 3 on top and then a 1 on the bottom and just get negative?
No.
Don't like
That would be the same concept as like trying to cross out these x's here. And once, as long as you have addition and subtraction, you can't do any of that. But I can simplify this a little further. I have some like terms. What's plus 2 minus 3?
x minus 1
X minus 1. So I have x minus 1 over x plus 2.
and x minus 1.
X minus 1 over x minus 2. There's a couple of things I can do from here. Johnny, I want to show a particular one first. I think I know what you're going to say, but I don't want you to say it yet. Okay? You talked about...
I was going to say you flip the
Oh, you got it. Perfect. That's exactly what I was going to... Okay. Fraction bar means division. You guys remember way back in 5th grade, if you're dividing one fraction by another, what you do?
Flip it.
Flip it. So if I have x minus 1 over x plus 2 divided by x minus 1 over x minus 2, isn't that the same as x minus 1 divided by x plus 2 times x minus 2 over x minus 1?
Yeah. So then it would be just x minus 2 over, or yeah.
Yeah.
The x minus cross that out and cross that out.
Can't see.
I can cross that out. Those two factors, I can cross them out.
X minus
And then you do what you did up there, and you just don't make the little side notation, and then we're all happy.
Yeah. Don't make that's right. And now we don't have to worry about it in this case. So I've got x minus 2 over x plus 2. Incidentally, if you're really confident about this, one thing you can notice, and Johnny, I thought you were going to jump to there, since this will always work out that way, if you have the same factor in a numerator in both the top and the bottom fraction, I could have just crossed them out from here. But you want to be careful with that. That's easy to screw up.
have to still flip it.
And then I still have to deal with, the 1 over x plus 2 and the 1 over x minus 3.
Well, I mean,
No, you're saying like the answer, like.
you just flip that.
Yes, and then you'd have a reciprocal, take the reciprocal of the whole thing. Yes, exactly. That pattern will hold, but you want to be careful with it. If you think you'll mess it up, show these steps. If you think you might have messed it up and you want to make sure you get the most partial credit from me, show these steps. Okay? Now, however, we haven't even begun the problem yet. The problem said the graph.
Bill.
Okay? So, well said. James, follow me over to camera 3.
Doesn't make sense.
It's a quote from The Daily Show.
Oh.
Whenever Jon Stewart wants to talk directly to like a world leader or something, he says, meet me over at camera 3. Then he turns at his desk and he talks into a different camera as if he were talking to Barack Obama or John McCain or somebody like that. Okay, for this graph, let's see what we need to know here. Right now, this is all we have to graph. Real quick, what's my horizontal asymptote going to be? Let's do that one first.
2.
Nope.
Minus
Negative 2.
minus
That's
one.
going to be a different order. Horizontal asymptote.
Minus one.
Why 1?
Because it's
Oh,
the same exponent.
Same degree, top and bottom, first degree. So you go with the ratio of the leading coefficients. That's 1x over 1x. Y equals 1 is my horizontal asymptote. Do I have a vertical asymptote or 2?
Yeah.
Where is it at?
2. No, wait.
Where's my vertical asymptote? Vertical asymptote comes from zeros on the bottom. So it is x equals negative 2. The 0 on the bottom. Do I have any x-intercepts?
No.
X-intercepts would be
Yeah.
where the numerator is 0 as long as there is no... Yes.
2 and minus 2?
No, it's just 2.
Just 2. 0, comma... I'm sorry, I wrote that backwards. 2, comma 0 would be my x-intercept. The only reason why a 0 on the top would not be an x-intercept is if it was also a 0 on the bottom, and then it's one of them buttonhole removable discontinuities we just discussed. Okay? So now you've always got to double check to make sure your zeros aren't duplicated on the top and bottom. Okay? That's the only thing you have to worry about for these rules. There's my x-intercept.
Y-intercept?
Y-intercept,
minus
thank
one.
you. Y-intercept,
Yeah.
Or
Negative 1.
positive 1/2, I think. I put 0, no, I'm sorry, negative 1, you're correct. I'm looking up here for some reason. Put 0 in for both x's, I get negative 2 over 2. And y, not y, y-intercept is the point 0, comma, negative 1. A very quick sign chart, sign analysis. I've only got 2 factors. If I put the